Alright, in this tutorial we're going to learn how to size a low pressure system. In reference to the code book that we're using, we're going to be using the most up-to-date code here, which is B149.1.20, so the 2020 gas code. The first thing you want to do when it comes to sizing a low pressure system is you want to have a sketch of your system. It's a 9-step process, and making a sketch is step 1. So we can go ahead and write this down here. The first one, sketch system. The second step is we want to identify what type of gas that we have. We could be using natural gas, propane, or butane. So step 2, identify our gas. Step 3, we want to identify what type of piping we are using. Is it copper or iron pipe, welded? Those are just a few examples. So step 3, we're going to identify the type of piping. Step 4 is we want to see what type of pressure we have on the system. Now anything up to and including a half psi is considered low pressure. And as we're sizing low pressure system, we have a 7 to 14 inch water column pressure on the supply side of our meter. So step 4, identify system pressure. Okay. Step 5, we're going to select our correct sizing table based on the information that we've got in our first 4 steps. But for now, let's go ahead and write all the 9 steps so we can go over this in a methodical way. So step 5, we're going to identify correct table in the gas code. In the code. Step 6, we're going to calculate the load on each leg of our drawing. Again, I'm going to go through this and size the above drawing in a methodical order. So for now, let's just write out our steps. So we're going to calculate the load on each leg. Step 7, we're going to calculate our longest measured run, or LMR. And the longest run is simply the longest route that we need to supply gas to. And I'll go over that in a little bit more detail here shortly. Once we've done that, we're going to locate on our table the correct code zone. Step 9, once we've established our correct code zone and the correct table, is to simply size each section within our code zone. Within code zone. Perfect. Okay, so step 1 is we want to sketch our system. And when you sketch it, you want to take note of the BTU content on each leg, as I've indicated here. So we got probably a fireplace or something like that, 30,000 BTU. We could have a hot water tank and a furnace. So a small system. The other things we want to take note of is identify the gas. In this case, we have natural gas. We need to identify the piping. And if we look on the table here, or our sketch, we've written down iron pipe. So we know that. And then we need to identify the system pressure. Okay, and again, as indicated here, we have 7 to 14 inches pressure from our utility provider. Now, the other thing about identify our system pressure is we want to go with a table that's going to allow for the maximum pressure drop. So as I show you this table in our gas code, since we have 7 to 14 inches water column, we're going to use table A2A because we have the maximum capacity of 1000 BTU for Schedule 40 pipe or plastic pipe, including the fittings, for pressures of 7 to 14 inches water column, based on a pressure drop of 1 inch. There's another table, the A2 table, and it allows for only a 1/2 inch pressure drop. Now we want to go with the maximum so we can get the smallest pipe with the highest pressure. This is why we want to always revert to the maximum pressure drop if we can. Okay, so let's continue on. We've made our sketch. We've identified our gas. We've identified our piping. And we've identified our system pressure. Now, based on those items, again, we're going to go with our table A2A. Now we're going to calculate the load on each leg. So on the first one here, let's jot down, this will be section A, section B, and this section over here will be C. So we have 3 legs or sections that we're going to size. For A, we have our 40,000 BTU water heater and our 100,000 BTU furnace for a total of 140,000. On B, all we have is our fireplace, which is 30,000. And on C, we have to supply both of those legs or sections. So we need to add our 140 to our 30 for a grand total of 170. Okay. Now, what we need to do is calculate the load on each leg. After that, we can calculate the longest measured run. So we'll check that, and we're going to check that. Calculate the longest measured run. So that means we're going to start at the meter, and we're going to add up our measurements of these legs. So starting at the meter, we got 10 feet, 15 feet, so it's 25, and then another 8, so we should come out to 33, 6, 7, yeah, 33 feet. Now if we forget this one for a moment, because this one obviously looks like it's going further, we need to supply to the longest measured run. So we have 10, 15 for 25, 30, 40. So this way we had 33, this way we got 40. So we're going to go with that. So we have LMR 40 feet. All right, now we established that. So now we're going to refer to the table, our gas code. We have A2A. And if you look on the left-hand side, you have length of pipe, and it goes in intervals of 10. What we need to do is we need to go with the highest measurement on here. So let's just say we know we have 40 on our longest measured run. Okay, so we have 40. So we're going to go 10, 20, 30, 40. This is now our code zone right here. And that's the one we're going to stay with. We're not going to jump around, because when we come to size, if you have 8 feet here, it doesn't mean we can go back up. once we've established our longest measured run, we need to stay within this code zone. So we're going to be taking our measurements from this line only. And if you look above here, your length of pipe is here and your pipe sizing is all along here. So once we've established our code zone, which we've done, it's 40. We're going to size each section within our code zone. Okay, so now we'll revert back up to our measurements. So working backwards from the longest measured run, we'll start with A. We need 140,000. So we'll go to our 40 code zone. We're going to move over to here. Now these are in thousands of BTU. So we need 140, but half-inch pipe is only going to supply 107,000 BTU. So we can't use that pipe. We need to go up. 3/4 inch pipe will serve up to 224,000. We need 140, so this would be a good choice to pick for our supply pipe. So pipe A would be 3/4 inch pipe. Pipe B, we need 30,000, as we've indicated. So if we move over to our first selection here, half-inch, will serve up to 107,000, and we're well within that, so we can put half-inch pipe for that one. C, which is supplying the whole area, comes out to a grand total of 170,000 BTU. Staying in our code zone, we move over. Half inches isn't going to do it. 224,000. Well, that's certainly more than 170, so we can stay with 3/4 inch pipe. Now, we don't have to worry about the fittings that are used here on low pressure systems because the sizing tables take into account a reasonable amount. So keeping a linear design as we have here, these tables would be more than accurate for us to size this system properly. So what we would end up with is this section, 3/4, this section, 3/4, and this section would be half-inch. So we've selected each section with our code zone. We've sized our piping. We are done for this project. Now we can get to work and start threading some pipe.